Hi, this is Mr. Siri, and this summer I had the opportunity to work in the Civil and Environmental Engineering Lab at Northeastern University. This video is meant to summarize the experimental procedures I carried out throughout the summer. But before I get to that, I'd like to share with you an overview of the PROTECT project, and the team of which I was a part. The acronym PROTECT stands for Puerto Rico Test Site for Exploring Contamination Threats. This project studies the exposure to environmental contamination in Puerto Rico and its contribution to preterm birth. The project also seeks to better understand what affects the fate and transport of hazardous substances in groundwater and to develop green remediation strategies that lower or eliminate exposure so that human health and ecosystems are protected. The principal investigator who welcomed me to his team for the summer was Dr. Akram Al-Shawabka. Dr. Al-Shawabka is the George A. Snell Professor of Civil and Environmental Engineering at Northeastern University, and is at the forefront in the field of geotechnical engineering. He and his team suggested that I undertake studying chlorobenzene in a batch reactor system. It's the first step in the investigation of remediation for this contaminant. So, let's go to the lab and see what happened. Okay, so we're going to go in the lab. Hey Mark, how you doing?
Hey,
nice
Rocco,
to see you
how's it
again.
going? Good
Awesome.
to see you. You need to come in?
I'll be right in here. There we are. Okay, so water has been delivered, and we're going to put in some sodium sulfate, which I pre-measured in a different lab. And that 570 milligrams. Turn on the stirrer. I'm going to add palladium. I need to crush it a little because some of the pieces are a little large, so crush that as much as possible. As you can see, the water is getting really sort of mucky and dirty. Just checking to make sure I get all the palladium that I measured in there. Last few bits of dust. Okay. And the next thing I'm going to add is ferrous sulfate for 6. I'm going to take 10 milliliters of a saturated solution of water and chlorobenzene, one of the chemicals that is toxic to our environment. Add it to my reaction vessel. Okay. Seal off as much of this as I can quickly. Place my second electrode in. And for the moment this is set up, we're going to leave it for 5 minutes and allow it to equilibrate. Okay, so we're going to connect our cathode and anode to the electrical power supply. And right here. And in about 4 minutes, I'm going to track the first sets of chlorobenzene and ferrous and ferric ions in solution. Right, so we're back at the lab, and we're going to be working with this HPLC machine. So why don't you come over, and we'll put the samples in. And I'm just going to quickly count them off so that I put them in this little area. Everything's automated in the machine. It picks up the sample, brings it over to a aliquoting device, takes the sample through all the different areas and then to a column, and the column is a more important part because that's where the analysis actually happens. And it's a time-sensitive thing, so as the chlorobenzene is found, it will elute out at about 1.572 minutes. So it takes about that long for the sample to go through. So each of these samples is going to go through in about 3 minutes. Alright, so here we are at the spectrometer. This machine reads the absorbance at a particular wavelength of light, and what that means is it basically looks at the color of my sample and sees whether light can pass through it or not, which would be right here, 0.125. And then I move on to the next sample. We'll do one more just so that you can see that. Pour in my sample, check for bubbles, place in the machine, close the lid, hit the read button, wait for the reading, and put it in my notebook. And so what this is going to check is the amount of ion in my sample, and that's it.
I wanted to take a moment to thank Professor Al-Shawabka and his graduate students Lily and Allie, as well as the team at Northeastern University Center for STEM Education, Claire Duggan, Mary Howley, Mark, and all the rest, without whom these opportunities would not be possible.